Have you ever been in a big building, like a hospital or a data center, when the power flickers for just a second and then, boom, everything just comes right back on? Well, that's not magic. It's actually a massive hidden world of engineering. So today, we're going to pull back that curtain and really dig into the tech that keeps our world running when the grid goes dark.
So let's really picture it for a second. You're in one of these critical buildings, and bam, total darkness. For a moment, it's dead silent. What is actually going on in that short, kind of tense pause before all the emergency lights kick in?
10 to 15 seconds. That's it. That is the entire window. In less time than it takes to fumble around for your phone in the dark, a building's entire emergency power system has to wake up, figure out the grid has failed, start a massive engine, get it up to speed, and then flawlessly take over the entire electrical load. It's incredible.
Now, this whole process, it has a name, mains failure operation. And what's so crucial to get is that this isn't somebody flipping a big switch somewhere. Nope. It is a completely automated, super high-stakes sequence where the system itself has to sense the problem and then execute a perfect solution, all without a single human touching anything.
And the hero of this whole story, the absolute workhorse that shoulders this immense responsibility, it's almost always the good old diesel generator. I mean, this is the technology that's been tweaked and perfected for decades to be the ultimate backup plan when the power goes out. And you know, while these machines are incredibly versatile, I mean, they're used to cut down on electricity costs or even act as the main power source for some places, today we're zeroing in on their most critical role, standby power for a mains failure, the job that really saves the day in an emergency.
It is so easy to just think of a generator as, a big engine in a box, but that's kind of like saying a Formula One car is just an engine with wheels. The reality is, it's a deeply complex, totally integrated system where every single part has a vital role to play.
So let's break down the anatomy of this thing. At its core, of course, you have the engine and the alternator. That's the heart, right? It's what actually creates the power. But that heart is completely useless without all its support systems. An automated fuel system to feed it, a gigantic cooling system to stop it from melting, and an exhaust system to handle all the fumes. And the thing coordinating every single part? That's the control system, the electronic brain making every split-second decision in those crucial 15 seconds.
You know, the source material for this explainer puts it perfectly, and I love this quote. It says, generating sets are big, heavy, noisy, and smelly. I mean, let's be real, this isn't something you can just tuck away in a broom closet. Just figuring out where to put one of these behemoths inside a modern building is a massive engineering puzzle all on its own.
And this illustrates the puzzle perfectly. You've basically got two choices, basement or rooftop. Do you put it in the basement? Well, that's great for running fuel lines, but then you need these enormous ducts. We're talking 4 square meters for a decent-sized set just to suck in enough cooling air. Or do you put it on the roof? That's perfect for air and exhaust, but now you have to structurally reinforce the entire building just to hold its immense weight, not to mention running gigantic power cables all the way down. There's no easy answer.
Okay, so here's where things get really interesting. Let's say a building needs 1200 kVA of power. That's its total demand. Logically, you just go out and buy a 1200 kVA generator, right? It seems simple. But this exact assumption is where a system can, and very often does, fail spectacularly.
And that's because the real challenge for a generator isn't the steady running load. No, the true test, the thing that will bring a system to its knees, is the massive, instantaneous surge of power that's needed to start big equipment, especially those huge motors in things like elevators and air conditioning systems. Let's just walk through this little story. Your 1200 kVA generator is humming along, supplying 900 kVA of power. Everything's fine. Then, a 300 kVA air conditioning chiller needs to start. But here is the kick. For just a few seconds, that chiller needs 3 times its running power to get going. That's a surge of 900 kVA. So you add that to the 900 you're already using, and suddenly you're demanding 1800 kVA from a 1200 kVA generator. The result? Total system overload. The whole thing just collapses.
So how do engineers prevent this total catastrophe? Well, they do it through some really clever electrical choreography. That control system, that brain, is programmed with a very specific startup sequence. It staggers the big loads. It'll bring on the fans, then the pumps, then the chiller, sometimes using physical interlocks to make it impossible for 2 big motors to start at once. It's like an electrical ballet, all designed to manage that surge and respect the engine's limits.
And really, that's what this all boils down to. You just can't plan for an average day.
A standby generator system has to be engineered for the absolute worst possible moment, a total blackout on the hottest day of the summer when every single piece of equipment is trying to come online at once. Reliability is, quite literally, everything.
And here's one last kind of counterintuitive piece of the puzzle. To keep them reliable for the long haul, these massive engines are actually designed to be run hard, ideally at about 70 to 80% of their full capacity. If you run them at very low loads for too long, it could actually damage the engine. So it's a machine that is truly built from the ground up for the worst-case scenario.
So the next time you're in a building and you experience that brief moment of darkness before the power is magically restored, think about that unseen symphony. A failure being detected, a massive engine roaring to life, cooling systems kicking in, and a smart little control box carefully choreographing this incredible sequence of massive electrical loads, all to bring your world back online in under 15 seconds. Pretty amazing.